Hi everyone, I am Dr. R. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. The subject is EC3351 Control System. Unit 4 is Concept of Stability Analysis. The topic is Root Locus Concept and Construction of Root Locus. After the completion of this video, the students can be able to explain how root locus adjusting the location of closed loop poles, construct and sketch the root locus for given system. The root locus technique is a powerful tool for adjusting the location of closed loop poles to achieve the desired system performance by varying one or more system parameters. Consider the open loop transfer function of the system g of s equal to k by s into s plus p1 s plus p2. The closed loop transfer function of the system with unity feedback is given by c of s by r of s equal to k by s into s plus p1 s plus p2 plus k. The denominator polynomial of the transfer function c of s by r of s is the characteristic equation of the system. The characteristic equation is given by s into s plus p1 s plus p2 plus k equal to 0. The root of characteristic equation is the function of open loop gain k. When gain k is varied from 0 to infinity, the root of characteristic equation will take the different value. When k equal to 0, the roots are given by open loop poles. When k tends to infinity, the roots will take the value of open loop zeros. The path taken by the roots of characteristic equation when open loop gain k is varied from 0 to infinity are called root locus. For the single loop system is given by g of s by r of s equal to g of s by 1 plus g of s h of s. The characteristic equation is denominator, that is 1 plus g of s h of s equal to 0, denominator equal to 0. From this, g of s h of s equal to minus 1. The above equation can be converted to two Evans conditions, that is modulus of g of s h of s equal to 1 and is less than angle of g of s h of s equal to plus or minus 180 degree 2q plus 1, where q equal to 0, 1, 2, 3, that is angle of criterion. The magnitude criterion states that s equal to sa will be a point on root locus if for that the value s of g of s h of s equal to 1. The angle of criterion states that s equal to sa will be a point on root locus if for the value of s angle of g of s h of s is equal to an odd multiple of 180 degree. The exact root locus is sketched by trial and error procedure. In this method, the poles and zeros of g of s h of s are located on s plane on the graph sheet and trail point is equal to sa is selected. Procedure for constructing root locus: first locate the poles and zeros of g of s h of s on the s plane. The root locus branch starts from open loop pole and terminates at zeros. Let n is the number of poles and m is the number of finite zeros. Now m root locus branches end at finite 0. The remaining n minus 1 root locus branches will end at 0. Second one, determine the root locus on the real axis. To determine the part of the root locus on real axis, if the total number of poles and zeros on the real axis To the right of this test point is odd number, then the test point lies on the root locus. If it is even, then the test point does not lie on the root locus. Next, third one is determine the asymptotes. The angle of asymptotes equal to plus or minus 180 degree into 2q plus 1 divided by n minus m, where q equal to 0, 1, 2, 3, that is the centroid. Centroid equal to sum of poles minus sum of zeros divided by n minus m. Fourth one, find the breakaway and break-in point. The breakaway and break-in points either lie on real axis or exist as complex conjugate pair. If there is a root locus on real axis between two poles, then there exists a breakaway point. If there is a root locus on the real axis between two, then there exists a break-in point. Let the characteristic equation b of s plus k into a of s equal to 0 from this point k, then k equal to minus b of s by a of s. The breakaway and break-in point is given by roots of the equation dk by ds equal to 0. Fifth one, angle of departure and angle of arrival. If there is a complex pole, then determine the angle of departure from the complex pole. If there is a complex 0, then determine the angle of arrival from the complex zeros. Angle of departure from that is equal to 180 degree minus sum of angle of vector to the complex pole A from other poles plus sum of angle of vectors to the complex pole A from other poles. Angle of arrival at a complex A that is equal to 180 degree minus sum of angle of vectors to the complex 0 A from other zeros plus sum of angle of vector to the complex 0 A from poles. That is shown in figure. Next, find the points where the root locus may cross the imaginary axis. The points where the root locus intersects the imaginary axis can be found by root array by trial and error approach. Let us say s equal to j omega in the characteristic equation and separate the real part and imaginary part. Two equations are obtained. One by equating the real part to 0 and other by equating imaginary part equal to 0. Solve the two equations for omega and phi we can found. Next, 7th step, take a series of test points in the broad neighborhood of the origin of the S-plane and adjust the test point to satisfy the angle of criterion. Sketch the root locus by joining the test points by smooth curve. The value of gain k at any point on the locus and we determined from the magnitude of condition, that is k equal to product of length of vector from open loop pole to the point s equal to sa, product of length of vector from open loop zeros to the point s equal to sa. The quiz questions are: what is the root locus? What is the magnitude criterion? What is the angle of criterion? How will you find the gain k at a point on the root locus? What is centroid? How will you find the angle of asymptotes? Thank you.